If 3i Atlas does turn out to be an artificial object, what do you think that would mean for humanity's understanding of its place in the universe?
Well, first, I would worry that humanity would not continue beyond October 29th, 2025. That would change the future of humanity. Just imagine what may happen. Suppose it's a functional spacecraft, and suppose that the trajectory was designed, and that's why it arrives closest to the sun when we are on the opposite side, so observers from Earth cannot figure out what it does on the opposite side of the sun. Does it really want to visit the Earth or something else? It could also send probes to various planets along its path if it's a mothership. So I would like to see whether it has a cometary tail or not. We usually talk about existential threats from artificial intelligence. A lot of people talk about AI becoming smarter than us, taking our jobs, leading us to extinction in one way or another. Not many people talk about the possibility that a visitor from outer space might threaten humanity. The question is, what is really their intent? There are two possibilities. Either they come at peace or they have malicious intent. They really want to destroy what we have or conquer it.
Thank you so much, Dr. Avi Loeb, for joining us in this two-part podcast. Our previous two episodes with you gained much attraction, and I'm looking forward to our discussion today. Welcome to the show.
Thanks for having me.
Professor Loeb, your recent articles on 3i Atlas have sparked a lot of interest. Can you start by giving us a basic overview of what 3i Atlas is and what makes it so unique compared to other interstellar objects?
Yeah, so this object was discovered on July 1st at a distance of about 4.5 times the Earth-Sun separation. And it was tracked, and some amateur astronomers realized actually it's moving faster than the escape speed from the solar system, so it's interstellar. This is the third recognized interstellar object over the past decade. What's special about it is that it was discovered with a telescope of 0.5 meter, a relatively small telescope called the Atlas Survey Telescope. And the reason it was discovered is because it was extremely bright. And actually, ironically, at the same time that it was discovered, the Rubin Observatory was inaugurated in Chile, very close to where the Atlas survey is taking place. And the Rubin telescope is 8.3 meters in diameter, much bigger, an order of magnitude, or actually more than that, bigger. So how come this small telescope scooped it? Well, the object is very bright. And I calculated immediately. So I had to wake up very early in the morning, around 2 a.m., because I had a radio interview on Coast to Coast in the US. And they asked me to wake up early because they broadcast after midnight. And by chance, one of the listeners sent me an email saying there is this new object just discovered, and that's quite rare because we had only 3 of them over the past decade or so. So I immediately checked it out, and I calculated that its size, if it's a solid object, has to be 20 kilometers in diameter. That's a huge asteroid if it is an asteroid. Twice as large as the asteroid that killed the dinosaurs, the non-avian dinosaurs 66 million years ago. And I immediately realized it doesn't make any sense because the first interstellar object was Oumuamua. It was about 100 meters in diameter. This one is 200 times bigger if it is an asteroid. We should have seen about 1 million objects that are the size of Oumuamua before seeing one that is 20 kilometers in diameter, based on the statistics of small and large objects in the asteroid belt of the solar system. So I thought this makes no sense. And a couple of days later, I submitted a paper that argued that if it's probably a comet, and so the size of 20 kilometers is from some cloud of dust surrounding an object that evaporates. And in that case, the size of the object, the core, the nucleus of the comet, has to be less than 1 kilometer. And I did this calculation based on the fact that there is a limited amount of rocks in interstellar space. You can basically take all the heavy elements, put them into rocks, or do some simple calculation of how much is ejected from planetary systems. And it led me to conclude that if this is a comet, the core needs to be less than a kilometer, much smaller, factor of 20, smaller in size, and 20 cubed smaller in mass than the 20-kilometer diameter asteroid. The only problem is when observers looked at the spectrum of this object, they didn't see any evidence for gas, molecules of a cometary plume of gas and dust. Also, if you look at the images, I mean, there is a little bit of fuzz around the object, but it doesn't look like the second interstellar object that was named Borisov, where you could see clearly cometary tail from the start. So I wasn't sure that it's a comet, and clearly it's not an asteroid because this will run into issues with abundance of rocks. And then a few days later, together with two collaborators, we started writing a paper where we suggested maybe it's not a natural object because the trajectory is very special. It turns out that it comes exactly within 5 degrees of the orbital plane of the Earth around the Sun. And the chance of that happening is 0.2%. And moreover, it arrives closest to the Sun when the Earth is exactly on the opposite side of the Sun. So the Sun will occultate it. There will be an eclipse of the object. We won't be able to observe the object when it's closest to the Sun. Why would that be the case? It's a very small probability for that to happen, a few percent. Then, on top of that, you can say, okay, suppose it had these orbital parameters, you just fix them, but then you just randomly select an arrival time. And you find that in less than 0.005% of all cases, it arrives as close as it does in reality to Mars, Venus, and Jupiter. So this orbit, this trajectory, has very special, unusual properties that the object gets close to the Sun when we can't see it, and also gets close to all the inner planets other than the Earth. And so we were wondering, maybe it's a technological artifact, in which case it might be consistent with the idea of the dark forest, which was a solution to Enrico Fermi's question, where is everybody? When Enrico Fermi in 1950 discussed extraterrestrials, he asked, why don't we see them? And of course, for 70 years, we've been searching for radio signals. We haven't heard anything. And one possible solution is that they exist. It's just that they are silent for a purpose because they're worried about predators. And also when a newcomer, a new civilization like ours, young in its technologies, emerges, the first thing they would do is, instead of revealing their existence, they would come and get close to Earth to figure out what's happening, and maybe with even hostile intentions to suppress any other young civilization that may pose a threat for them. And so in this context of the dark forest, you might expect reconnaissance missions where some probe will come on a very prescribed, designed trajectory. Now, it's easy to figure out if that's the case, because as in the coming months, the object will get closer to the Sun, and before it gets hidden behind the Sun, we should be able to tell if it's a comet. If it's a comet with a nucleus of less than a kilometer, then I would say, okay, maybe the trajectory is just completely, a coincidence. It so happened, but it's very unusual, but sometimes unusual things do happen. However, if it doesn't look like it's a comet and it looks like a solid object, or if the nucleus of the comet appears to be above 10 kilometers in diameter, then I would argue something really is unreasonable here, because it doesn't square with the mass budget in rocks in interstellar space, and maybe there is something to it.
Wow, that is so much. Thank you so much for sharing. That is such a beautiful insight.
I should also mention one more thing. It came from the direction of the galactic center, where that region of the sky is very crowded in stars. And that's why it was not easy to detect it until July 1st, 2025. by now we have no way of actually launching a rocket that would land on it or intercept it, because when it comes close to the sun, it would move in the opposite direction of the Earth. It actually, that's another interesting property of its trajectory. It's opposite to the Earth. It would move at 68 kilometers per second, while the Earth is moving at 30 kilometers per second in the opposite direction. Altogether, the relative velocity would be 98 kilometers per second. That's 3 times the maximum speed of a rocket that we ever launched to space. And we just cannot reach it. And so that's another. And if we were to detect it a year earlier, we could have intercepted it. There was enough time, but by now there is not much time left before it gets to us. It will come closest to the sun on October 29th, 2025. And my recommendation is, if you are planning a vacation, take it before that date.
You just mentioned the trajectory. So the trajectory of 3I Atlas is somewhat irregular. How can you differentiate between a naturally occurring anomaly and one that may be the result of an artificial influence or technology?
Right. So I actually wrote several essays over the past week, and one of them was how to tell the difference between a spacecraft and a rock. And I suggested various ways of doing that. Obviously, if there is evidence for propulsion, for non-gravitational acceleration, that would be indicative of perhaps a technological device. If there is no cometary evaporation, it cannot be the rocket effect from the evaporation. One can also examine the surface composition from taking a spectrum of it. One can also, of course, fly by and take a close-up image and see what it looks like, or even land on it, potentially, if we know about it sufficiently ahead of time. So there are various ways of telling that it's artificial versus natural. And of course, I think it's extremely important to keep always the possibility of a technological visitor on the table, because it would, to ignore it up front is not intelligent. I mean, we just don't know what lies outside the solar system. And the strange thing is, I do see a lot of resistance to considering that possibility from the SETI community. This is the community that was searching for radio signals. And even today, this morning, someone forwarded the blog post to me where a SETI astronomer is basically ridiculing the possibility that 3I Atlas could be technological and, trying to attack me personally. I think it's just inappropriate because it's not professional. If there is a scientific argument, it should be cleared through. I wrote 2 scientific papers, submitted them for publication. One was already published. And that's the way to do science. Pay attention to the evidence. If there are anomalies, let's discuss them. There is nothing wrong in having an interpretation that with future data will be proven wrong. I mean, that's the way science is done. And there are plenty of examples by which we learn something new by having made mistakes and realizing that actually the explanation is different than we anticipated.
Well said. Well said. Professor Loeb, considering that 3I Atlas is so much smaller than previous interstellar objects we've studied, do you think it could change our understanding of the frequency and distribution of these objects in our galaxy? And please feel free to elaborate.
Yeah, it really depends on the nature of this object. If it's a comet with a nucleus that is less than a kilometer, then it would be not very different from Borisov, the second interstellar object. And then, we will have another data point on a comet that comes from outer space. And comets are the most natural things for us to expect because they are basically rocks with an icy surface, so that when they get close to the sun, the ice evaporates and you end up with a plume of dust and vapor, water vapor and gas surrounding the object that reflects sunlight. That's what a comet is. Now, these icy rocks are made in the outer parts of planetary systems. So in our case, in the solar system, most of these comets exist or originate in the Oort cloud, the outermost layer, the spherical region around the sun, going out to 100,000 times the Earth-Sun separation. So the thing is, this is halfway to the nearest star. And if there is another star passing by, it will most likely rip apart those loosely bound Oort cloud objects because they're sitting in the outskirts of the solar system, and they have very little binding energy to the sun. They move very slowly. So a passing star can easily kick them out. And therefore, you would expect to have in interstellar space all these icy rocks from the outer parts of planetary systems. And I would have expected, if someone would ask me a decade ago, I would have said, and in fact, I wrote a paper about it 15 years ago, that most of the interstellar objects would be comets, or almost all of them. But so the question is, what is 3I Atlas? If it's like Borisov and not very different in size, the size of Borisov, the diameter was less than 400 meters. If this one happens to be a kilometer or maybe twice as large as Borisov, that's not a big deal. You know, it's you have a distribution of sizes. However, if it ends up being an object that is bigger than 10 kilometers, much bigger than that, the amount of mass associated with it goes like the size cubed. And there is just not enough mass in rocks in interstellar space to bring one such giant rock 10 kilometers or bigger every 5 years to the inner part of the solar system. So the survey was, the Atlas survey was taking place for about 5 years. And so I would say in that case, if it's a big object, we have a problem. And one possible way to solve the problem, the abundance problem, is to say, well, it's not just randomly moving, it prefers to go to the inner solar system. And obviously, one way for it to prefer it is if by design, this orbit, this trajectory, selected the inner solar system, as is the case for a technological device. So if we find that this is an object bigger than 10 kilometers, and we know that the trajectory was quite unusual, it favored the orbital plane of the Earth, the inner planets around the sun, and therefore it will come close to several of them in the same passage. In that case, I would say one should take quite seriously the possibility that this is not a random occurrence, natural occurrence. However, if it turns out to be just a plume of dust that we've seen that reflects sunlight, and in the center of it there is an object less than a kilometer, then I would say everything is working well in terms of what we expect, except for the trajectory, which is still unusual, but that by itself is not sufficient to argue for an artificial origin.
Thank you for sharing. And I know you mentioned this before, but a lot of our viewers are interested on how these interstellar objects are tracked. If you can elaborate a little bit more on that, and how does your team at Harvard's Galileo project, what do they do to study and gather data on them?
Right. So basically, it's any object that is coming to the inner solar system can be tracked because it's moving much faster across the sky than the stars, the background stars that are very far away. Those stars are moving across the sky because the Earth is spinning, but then the object also has some intrinsic motion. And because it's so much closer to us than the background stars, by many orders of magnitude, you can actually see that it moves relative to the stars. And that's how the Rubin Observatory, they had an inauguration of the first light from the observatory a month ago. And in that inauguration, they showed some short videos. And one of them was about discovering over 2,000 asteroids from the main asteroid belt over a few nights of observing. So they found a few thousand new asteroids that were never known before. And they basically traced them by seeing moving objects, moving relative to the background stars. And when you do that, then you can eventually follow the object long enough so that you can trace the way it moves across the sky. You can get some curvature for the trajectory. And from that, you can try and fit it to an orbit around the sun. That's based on the law of gravity that originally Isaac Newton first realized. And so the gravitational acceleration from the sun changes inversely with distance squared, but the curvature of the trajectory tells you, I mean, you can find the appropriate parameters of the orbit, and then you can figure out if this object is bound to the sun or not. And the vast majority, for every several thousands or even more, maybe 10,000 objects that are bound to the sun, you will find maybe rarely, once in a while, you will find an object moving too fast to be bound to the sun, above the escape speed from the solar system, and that's what flags it as an interstellar object. The estimate is that the Rubin Observatory should find maybe up to 50 interstellar objects over the next decade, the next 10 years. So right now we have 3 documented, and we can increase that to 50 within the coming decade. My suggestion is that in each and every case, we must carefully check for the possibility that it might be technological in origin. If we find one, or even if 3I Atlas is one, that would change the future of humanity, because just imagine what may happen when this object, suppose it's a functional spacecraft, and suppose that the trajectory was designed, and that's why it arrives closest to the sun when we are on the opposite side, so observers from Earth cannot figure out what it does on the opposite side of the sun. Turns out that there is a maneuver that is called the Oberth maneuver, after the person's last name, Oberth, that is basically using gravity to add a thrust to the spacecraft. So usually what NASA does is come at closest approach to the sun, the rocket of the spacecraft gives a thrust such that you get a boost in the kinetic energy, the motion of the object, so that it can escape the solar system. And so this is a maneuver meant to accelerate the object, but you can do the reverse and brake. And so if this object, for example, wanted to visit the Earth or the inner planets, it could brake at closest approach to the sun. That would be the point where it's most effective. The use of the engine combined with gravity will give it the biggest brake. And in that case, of course, all bets are off as to what the plan is for it to do. Once it gets bound to the sun and brakes at closest approach, does it really want to visit the Earth or something else? And of course, it could also send probes to various planets along its path, if it's a mothership. So there are lots of interesting questions to ask if it's not a comet. And, even amateur astronomers could follow it when it comes closer to the sun, and that would be really exciting to watch. If it turns out to be a comet, so be it, and we can learn much more about the interstellar comets.
No, that's true. If it's not a common, there's so many questions arise. You touched upon this a little bit earlier, but just for our viewers, if you can elaborate that, given the nature of the data we have so far, are there specific characteristics or patterns you're looking for that would confirm whether the object's behavior is truly anomalous or just a rare natural occurrence?
Yeah. So the most important is whether it's a comet. So I'm really eager to see as it gets closer, we see a nice cometary tail, a plume of gas and dust. So far, it's very marginal. The claim is there is some fuzz around it, and actually, because of the motion of the object, the fuzz will obviously get smeared if you expose the camera over 100 seconds. Then you would get some elongation of the fuzz, which is observed in the images, but I don't think it's a result of the true shape of the object. It's more to do with the integration time. So I would like to see whether it has a cometary tail or not. That would be the first thing, most important. And then if it is a comet, how big is the core of this comet, the nucleus? Because once again, I predict that if it's a regular natural comet, it should be smaller than a kilometer in diameter. Let's see if it is. I made this prediction just a few days after it was discovered, and that paper is published. And if it is a natural comet, then it should be quite small. That's the foremost priority right now. And the next thing is, of course, whether it does any maneuvering, whether there is any evidence for non-gravitational acceleration, which could be evidence for an engine or for solar radiation pressure pushing it. It could be that it has a light sail that is used, or it could be that there is some engine that gives it propulsion. All of that should be evident from monitoring the trajectory and seeing if it deviates from a trajectory dictated just by gravity. So that would be the next thing to check. And then in terms of detailed observations of this object, there was already a spectrum taken by two teams, and they were looking for molecular molecules that usually make up cometary tails, and they didn't find any evidence for that. No evidence for water or carbon-based molecules so far. The only claim that was made is that the reflected sunlight is reddened. The object is red, so that could be a result of a plume of dust surrounding the nucleus of a comet, or it could be that the surface is red. And in fact, Kuiper belt objects in the outer part of the solar system, beyond about 100 times the Earth-Sun separation, they have red colors, and usually it's because their surfaces are bombarded by ultraviolet light from the sun or cosmic rays. And as a result, there are all kinds of organic molecules forming there, and that gives them a red color. This one is extremely red. Maybe it's simply a result of the surface exposed to cosmic rays throughout the billions of years in interstellar space. That's possible. It doesn't necessarily mean that there is a cloud of dust there. So I would like to see results also from the spectrum of the object as it gets brighter. If it's a comet, it should get brighter not just because it gets closer to the sun, but also because it will get hotter. The surface will get heated more, and at some point there would be much more evaporation than at large distances. So that the enhanced evaporation or breakup of the object would tell us a lot about its composition and how fragile the core is.
Professor Loeb, I know this possibly might be a question in many of our viewers that are watching this video till this point, which is why I really want to ask you this. Let's say that if 3I Atlas does turn out to be an artificial object, what do you think that would mean for humanity's understanding of its place in the universe?
Well, first, I would worry that humanity would not continue beyond October 29th, 2025. We usually talk about existential threats from artificial intelligence, right? A lot of people talk about AI becoming smarter than us, taking our jobs, leading us to extinction in one way or another. And people talk about also climate change. But not many people talk about the possibility that a visitor from outer space might threaten humanity. And that should be something on the table, especially as we start to detect more and more interstellar objects. And if we see an outlier that looks like a technological object, we should worry because, we worry about ballistic missiles that can be launched by other countries, right? And, most recently, Iran launched a lot of them. And North Korea could launch, and who knows? The Russians and so forth. But think about a ballistic missile that originates from a spacecraft that comes from outside the solar system. That may represent technologies that we don't possess. The question is, what is really their intent? And there are two possibilities. Either they come at peace, and they have no intention to harm us, in which case we should accept them with open arms, or they have malicious intent. They really want to destroy what we have or conquer it, or just think about what happened to the Americas, the indigenous people there when Europeans came along. We currently go to restaurants and we eat animals that we regard as less intelligent than we are. I went to a fish restaurant in Boston just a month ago, and they served the octopus, and I had a hard time accepting that because we know that octopi are quite intelligent, and so just think about them being more intelligent than we are. They could have us as their meal, for in their soup, or they will just do something that will change our future very dramatically. So that will be my first concern, and it's an immediate threat. You see, if you just get radio signals from 100 light years away from some source, yeah, it's so far away. There's plenty of, you don't need to respond immediately. They're not in a rush because the travel time of the signals is so long. We're talking centuries. And moreover, the time for them to arrive at our doorstep is very long. So I wouldn't be alarmed by a radio signal. But if, on the other hand, there is someone already in your backyard, that could be a threat, a real threat. And it's much more serious than an adversarial nation on Earth, because we pretty much know the level of technology that we possess all around the globe. But someone that had access to more than a century of science and technology, as we did, someone that had maybe a millennium of science and technology, might be capable of doing far bigger things than we can. And any attempt to prevent them from doing what they want might be futile. We might not be able to cope with them. And just because it's just like ants in the crack of a pavement, when a person passes by, I mean, the person can easily step on these ants. They have nothing to do against that. So I would be worried actually about that. If it turns out that they are friendly, which one can probably figure out and after the fact, then of course it could be a big boon to our future, in the sense that we can learn from them. It's as if you meet a smarter student in the class, that you can learn from, and we might learn about new physics, new science, and new technologies that we don't possess. I believe that as soon as it's realized that there is a technological object, the stock market would crash. And moreover, insurance companies would go crazy, and people will go out to the streets because governments cannot protect them. That would be a major historical event. And how people will behave is very difficult to forecast. Some people will just maintain their daily routines. They will ignore it, not look up. But, just like primitive animals, when humans pass by, they don't necessarily respond to that. But I do think that it would have a huge impact if indeed we are talking about a visitor that is just around the corner. If we are dealing with, just space trash, suppose we find a gadget that is not functional anymore, just like Voyager will be once it exits the solar system, or there is the Tesla Roadster car that SpaceX launched, and it's not operational. If we find that kind of space trash, then it's harmless, and it could still offer us the benefit of learning about others. That would be an easier scenario to deal with.
Wow, thank you for sharing. Dr. Loeb, I've been thinking, since interstellar objects like 3I Atlas pass through our solar system only briefly, according to you, what are the biggest observational challenges in capturing meaningful data before they're gone?
Right. So with Oumuamua, we were in much worse situation, because it actually passed the Earth on its way out when it was discovered on October 19th, 2017. So, and that's because it was quite small, didn't anticipate it, and it came close to Earth, so it was flagged as a near-Earth object. And once observers looked at the data, they realized, oh, that's an interstellar object. So it was surprising. and we didn't have enough data on it. In this case, with 3i Atlas, it was discovered on its approach towards us, and the reason is simple. It's much brighter. As I said, if it's a solid object, it's like 200 times bigger than Oumuamua. That's why we could see it coming in so far away. So that offers the advantage that we can observe it, in fact, until October 1st, before it gets close to the sun where we can't look at it. So we have several months to do that. And I'm sure that astronomers will use the biggest telescopes. For example, just to prove me wrong, I actually think it's very good that if people are sure that it's a comet, I would like them to get as much data as possible to demonstrate that they're right. Because if it's not a comet, they will have nothing to say. They will have already the data. So it's much better to have as much data as possible than to make an argument that we believe this object is something, which is the case of Oumuamua, where right now the mainstream of the comet expert community argues that it's a dark comet. In other words, it's a comet where we couldn't see the cometary tail, but nevertheless, it existed. It was transparent. We just couldn't see it. Just like the tale of Hans Christian Andersen, where the adults in the room say the emperor has clothes, you just can't see them. And the kid says, well, I don't see the clothes, and I feel like I'm the kid. So that's the explanation in the case of Oumuamua, that maybe it was a comet, but dark, which makes no sense in my mind. In this case, they cannot say that. We will have plenty of time to observe the cometary tail. If it's not there, then it would be really peculiar.
You mentioned Oumuamua. Now, the discovery of Oumuamua raised a lot of questions about interstellar objects. Do you think our scientific approach and mindset about these phenomena has shifted since then and impacted how we explore the 3i Atlas?
Well, I think people are more intrigued because when Oumuamua was discovered, it was assumed that it must be similar to the rocks we know within the solar system. But even the experts could not accommodate the observed facts about Oumuamua. It had an extreme shape, most likely flat, and its length relative to its thickness must have been more than a factor of 10, based on the fact that the amount of sunlight reflected from it changed by a factor of 10 as it was tumbling. So it was an unusual object, and at first the community said it's a comet, but then no cometary tail was found, and so they said it's an asteroid, but then it was pushed away from the sun and without evaporation, and so then they say, well, maybe it's a dark comet or all kinds of. So we still haven't figured it out. We don't have enough data about it to know what it was, and it could have been a technological relic, as I said, but. Now, because there was so much controversy about Oumuamua, and I was partly responsible for that because I wouldn't back down. I would not admit that it's a dark comet when we haven't seen the cometary tail. Why should I just bow down to what people wishful thinking is? You want it to be a comet, so you say it is a comet, and then you say, well, but we can't really see the evidence for a comet, so it's a dark comet. This is cheating. If you don't see the cometary tail, you don't know if it's a comet. And I don't like when people cheat in the context of science. So I just said, I don't know what it is. It could be artificial. Now, we really don't know what it is. And now comes another object. So hopefully we will get enough data on it. And I think that the fact that it was the verdict was unsettled for Oumuamua would make all future interstellar objects of great interest. And my hope is we will get so much data on them that it will be very clear in each and every case what the nature of the object is.
Professor Loeb, thank you so much once again for such an insightful conversation. I'm really looking forward to releasing this episode and looking forward to what the audience has to say about it. Thank you.
Thanks for having me.